All right, we're going to start here on semester 2 stuff. And we're going to start in Unit 5. And Unit 5 kind of piggybacks off of the Unit 4 stuff, which was proving that triangles are congruent. But in Unit 5, we're going to talk about similarity and proving triangles similar. So we're actually going to start on page 63 in our notebooks. And we'll get this unit set up. Okay, so Unit 5. Unit 5, we're talking about similarity. Okay, and similarities is what it sounds like. We're gonna mainly talk about triangles because every other shape can be formed out of triangles. So if two triangles are similar, that means they're the same shape, but they have a different size. Okay, we're going to go over to page 64, and we're going to write down our unit goals. I think before we talked, we'll label them learning targets. Okay, so learning target 5.1 is I can verify the properties of dilations to define similarity and establish this is angle similarity. Okay. 5.2 learning target . 5.2 learning target, I can use properties and relationships of similarity to justify figures are similar and solve for unknown measurements. Okay, so use properties and relationships of similarity to justify that the figures are similar, and then find some unknown measurements. And lastly, we have 5.3. I can use congruence and similarity of triangles to solve problems. Okay, and 5.3 is gonna kind of deal with word problems and kind of having to draw pictures of things and that kind of stuff. Okay, so let's kind of get into this first learning target. The first learning target here talks about dilations. So on page 65, we're going to talk about dilations. This unit is rather small and fairly quick, so it won't be too long before we're taking the test on this unit. Okay, so what is a dilation? A dilation is a transformation that stretches or shrinks a figure to create a similar figure. Okay, so with a dilation, it is a transformation, and we didn't talk about it with the other transformations because with a dilation, the size actually changes. With the other three transformations, the shape held the size and the same shape. But with this one, we're stretching or shrinking the shape. Okay, so it is changing sizes. So in that case, it is similar. On a computer screen, when you have a window, let me just share my whole screen here with you. So here on this screen, I have this window here, and I can click it and I can translate it wherever I want. But when I click a corner, I'm up here in the top left. When I click the corner and do this, this is a dilation, okay? It's staying the same shape, but it's changing sizes. Now, when I get so far, and if I were to go just up and down, that's not a dilation, okay? Because it changes the shape. But when I do the corner, or if I do the left side, this is changing the actual shape. But if you click the corner here, well, the corner doesn't tend to change the shape as much, okay? So we're just talking about shrinking or stretching. And on these dilations, you have something called a scale factor, which you've talked about before in Algebra 1. So scale factor or ratio. This is our K equals some number. Okay, it'll be noted as K equals a number. So this is a comparison between the pre-image and the image. Okay, this is a number that tells you if it got larger or bigger or anything like that. Okay, so there's a rule here, just like with a rotation or reflection or translation, we had a rule. So the rule for dilation would look like this: X, Y. So these are your pre-image ordered pairs, goes to KX, KY. So in this case, you're actually multiplying both numbers by whatever your scale factor is. Okay, and we're going to look at 2 examples here. And this one is find the scale factor and rule. Okay, so we're going to have a graph here. And the points are here. Well, let me change colors. I'm going to point here. Oh, that's still black. Here's blue. Get this one, this one, this one, this one. Okay, there's one. And then for the next one, here, 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 and here. Okay, so this would be, we're going to say that this is A and this is A prime. Okay, so A is the pre-image and A prime is the image. So looking at the A shape, that is smaller than the A prime shape. So going from this shape to this shape, it gets bigger. And the only way to make those numbers bigger is to multiply by a larger number. So kind of the first thing we can look at are the ordered pairs. So we can look, this is 2, 1, and this A is at 4, 2. So you can kind of see here that I go from 2 to 4 and 1 to 2. And we know that we have to multiply by something to get those. So 2 times what is 4, and 1 times what is 2. That would be 2. So from A to A prime, the scale factor equals 2. So your rule would be x, y goes to 2x, 2y. And there's something unique about dilations, and that is this is a dilation about the point 0, 0. And we can change whatever point we want to dilate around, but for the most part in this class, we'll be doing it around 0, 0. And sometimes the question may say, find the point of dilation. Well, this is the point of dilation. And I know that because if I connect A and A prime with a straight line, get a ruler out here. If I connect A and A prime with a line and continue that line in both directions, and if I do the other points, so we got this point and this point, Just draw a line there. And we'll do this point and that point. And then this point and this point. We can see that all of these lines intersect at 0, 0. Now in art class, you did this, and it was actually called vanishing points. And this point right here, this point of dilation, was called your vanishing point. And it's how you get 1 and 2 point perspective. Okay, next example here. Yeah, 1, 2, 3, 4, 5. 4, 1, 2, 3, 4, 5. So this is point B, and it's at 4, 5. Okay, so this is A, D, C. Okay, and we got another shape on here. W. This is W. Z. Here. And Y. Y. So W is at 0, 6. Z is at 3, 3, and Y is at 9, 0. Okay, so there's the picture that they give you. And it says if A, B, C, D, so A, B, C, D, this shape, is similar, this is the symbol for similar, to W, X, Y, Z, where is point X? Okay, so these two shapes are similar. So this W, X, Y, Z will look like this. So X is going to be somewhere way up here. In order to do this, I need to find the scale factor. Okay, and the easiest way, I think, you can look at any 2 points, but the easiest way I think of is looking at point D to point Z. Okay, D is at 1, 1. So D is at 1, 1. And point Z is at 3, 3. How do I get from here to here? Knowing, if we go back up here, knowing that we have to multiply. Okay, so we're not adding, we actually have to multiply. So what number times 1 is 3, and what number times 1 is 3? And we could also look at C to Y. So C is 3, 0, and Y is 9, 0. So what do you multiply 3 by to get 9 and 0 by to get 0? Okay, and that number is actually 3. So the scale factor equals 3, which is x, y goes to 3x comma 3y. So your new point, or your point for x goes with point B. So you have 4, 5 is B. And if you multiply both of those by 3, you get 12, 15. So 12, 15 is point X. So 9, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So X is actually way up here. Not even on my page. So I graphed X way up there. Okay. So you got to find the scale factor before you can find any of your points. All right. So let's flip the page onto page 66 and talk about types of dilations. So we're going to continue this. Actually, we're going to stop here. Well, we'll finish part of this, and then I'm going to stop so you can get some practice on doing those first examples. So some things that we can have with a dilation are an enlargement, and we can have a reduction. Okay, and I want you to maybe think about while you do some simple dilations, are what kind of numbers will give me an enlargement? What kind of numbers will give me a reduction? Okay, and we will look at those the next time we meet. Okay, so you'll have some practice here on dilation, and then I'll see you in the next lesson.